Today we're going to look at our last three set of exponent rules. It is titled 9.2 Exponents Day 2. Your objective instead of TSW should say I will be able to. Use the product, the power, the quotient, the zero, and the inverse rules to simplify exponential expressions. Now, yesterday or the day before, we went over the product rule and the power rule. What you're going to see new today is we're going to look at the quotient rule, the zero rule, and the inverse rules. Now, the good news is you've actually seen two of the three of these already in Unit 7, but they're going to come back more at a much deeper level today. Once you have your objective, go ahead and move on. The first rule that I want to know that you are writing in your notes is the quotient rule. Quotient means we're dividing. If we have two terms with the same base, they both have a base of a, we are going to take their exponents, the m and the n, and we're going to subtract them, m minus n. So take a moment and write that down, and then I'm going to show you what we mean and why that works. If we had x to the 11th over x to the 5th, that means we have 11 x's. Give me a second to write them all. 8, 9, 10, and 11. Over x to the 5th, which means we have 5 x's being multiplied in the denominator. Now remember, with any multiplication or division we've done before, anytime you have the same number or term, top and bottom, it reduces or cancels to 1. Just like x over x is 1, 7 over 7 is 1. So this x over x is 1, x over x is 1, and you will see that they all cancel out to 1 times 1 times 1 times 1 times 1, which is 1. And the question is, what do we have left over? We have 6 x's on top being multiplied. So our final answer is x to the positive 6th power, because the x's were in the numerator. Now, I'm not going to ask you, neither is Mr. Weiler, to write all of this out like that. What we would like to see on your paper is that you're going to, in fact, subtract the exponents. So, for example, we would have x to the 11th over x to the 5th would be x to the 11th minus the 5th, which is x to the 6th power. Now, the only difference you'll see in example B is when we have negative 24x to the 5th power over 6x to the 7th power. The difference here is that we have coefficients in front. You're going to treat those coefficients just like a fraction that you've reduced since about 5th and 6th grade. Negative 24 divided by 6 is negative 4. Now we're going to look at the exponents. X to the 5 minus 7. Notice the 5 minus 7 are up a little bit as my exponent. So that would be negative 4x to the negative 2nd power. Now what we have to be very careful here, this negative 2 exponent is attached to the x. The negative 4 is a negative coefficient, but there's only one of them there, so its exponent really is a 1. The 1 is understood to be there, that's why we don't normally write it in, but it is a positive 1. What you're going to see in just a few slides is any base that has a negative exponent, we will take its reciprocal. The negative 4 had a positive exponent, so it stays in the numerator. However, the x had a negative exponent, so it is taken the inverse of it. We flip it, send it to the bottom, and it becomes a positive exponent. If you remember way back in 7.1, we did introduce this idea. You're seeing it occur again, and it's going to occur throughout all of Unit 9 with our polynomial work. So the correct answer would be negative 4 over x to the 2nd. If you leave your answer as negative 4x to the negative 2nd, that is mostly right. Just like not simplifying or reducing a fraction, it will get most of the points on an assessment, but it will not get full credit if you leave your exponent negative. So make sure once you get down with your final answer that you change it and take the inverse. So let's go ahead and look at the next one. We're going to reduce our fraction with our coefficients. 15 divided by 3 is 5. For my x's, I'm going to take the x's exponents, 12 minus 9, and then we have the y's exponents, 7 minus 2. If I simplify, that would be 5x to the third, because 12 minus 9 is 3, and for the y, 7 minus 2 is 5. So the final answer is 5x to the third, y to the fifth. So just a reminder, we divided the coefficients, and then we subtracted the exponents of the like bases. The next rule that I'm hoping you are writing down is the zero rule. It says that any base to the zero power is 1. We also talked about this in the very beginning of Unit 7 as well. It is now going to show up again in Unit 9. So let's look. The whole term, 12x to the fifth, is to the zero power. Well, anything to the zero power is 1. If we have x to the 12th over x to the 12th, think about that as x to the 12 minus 12. Same base, so we subtract the exponents, and 12 minus 12 is 0. Anything to the zero power is 1, just for that one term. So now let's look at our last rule, the inverse rule. This is the one I was referring to on our first slide today. A to the negative n is equal to 1 over a to a positive n. So here's what that looks like. X to the negative fourth is really like x over 1. So if we take the inverse or flip it, the x moves from the numerator to the denominator, and it becomes a positive exponent. The 1 was in the denominator, now it's in the numerator. So x to the negative fourth is really the same as 1 over x to the positive fourth. So when we get done with all of our exponent work, any base that has a negative exponent must have its inverse or reciprocal taken. So to continue with that, look at example B. 5 over x to the 7th. The 5 has a positive exponent. It's really 5 to the first. It does not need to move. However, the x to the negative 7th, that's a negative power. It is currently in the denominator. So if I flip it, it moves up to the numerator and becomes a positive exponent. We could say it's the x over 1, but anything over 1 is just the term, 5x to the 7th. So look at our last example for this slide, example B, or C. We're going to take our fraction coefficients first. 12 divided by 2 is 6. Now the x has a negative exponent, so it must move from the numerator to the denominator. When you take the inverse, the exponent becomes positive. The y to the negative third would move up to the numerator for its inverse. So now, by switching which part of the fraction it's in, by taking its inverse or reciprocal, the exponents are all positive, and we are done simplifying. Please make sure that you have written this rule, and you have these 3 examples down. When you're ready, we're going to move on to now let's look at what order we use, because we have now seen all 5 exponent rules, 2 of them from the previous day, and the last 3 rules you have just seen. So number 1, you're going to check for 0 exponents. That's the first thing you're going to do to simplify. Once you've done that, you will look to see if you can combine like terms inside parentheses, if it's possible. Then you're going to swap the negatives to make positive powers. If you have a negative power, you take the inverse or reciprocal. If it is upstairs in the numerator, you send it downstairs to the denominator. Then we will use the power rule, which is from the previous day, like x to the third to the 4th power. Once that is done, we will go ahead and use the product of powers, which means we multiplied our constants or coefficients, and then we added or subtracted the exponents. So those are the 5 steps in the order, kind of like order of operations for exponents. Because normally with order of operations, we just say exponents, and that's all we've ever thought about. But now within exponents, it has its own list of order for the rules. So let's go ahead and look at a few problems and see if we can combine our rules. Look at example 1. I'm hoping that you see the first thing you're going to do is simplify your coefficients. 28 divided by 4 is 7. If I look at x to the 8th over x to the 3rd, they are the same base. So I'm going to take their exponents, and am I going to add or subtract them? That's right, we're going to subtract them. So that would be 7x to the 5th power. That's it. Let's look at our next one. Take your coefficients, 24 divided by 6, that is 4. X's will be 13 minus 8, because those are the exponents of the like letters. For the y's, it will be 5 minus 8. If we simplify, we will get 4x to the 5th, y to the negative 3rd. Do you see anything that needs to be simplified? I'm hoping that you see the 4 and the x to the 5th do not need to move. It is only the y that has the negative exponent. So only the y gets sent to the denominator for its reciprocal to become a positive exponent. The final answer is 4x to the 5th over y cubed. Once you have that down, go ahead and move on. Here's our zero rule. The whole term in parentheses is to the 0 power. So the answer is just 1. That's it. Now, do not get fooled by this next one. What is the base that's to the 0 power? It's just the x. X to the 0 power is 1. That is still multiplied by y to the 3rd power. Well, 1 times anything is just itself, so the answer would be y to the 3rd. So let's take a moment and use our inverse rule, or reciprocal. The x has a negative exponent in the numerator, so we will send it downstairs to become a positive exponent. The y also has a negative exponent in the denominator, so we will send it upstairs to the numerator to become a positive exponent. We're using the inverse or reciprocal rule. Now let's be very careful. This is where showing work for number 6 is going to pay off in the end. We do have a 4 on top. When we subtract our exponents, I'm going to highly, strongly suggest and urge you write this out. You're going to see 2 minus negative 4, and if you go too fast, you're going to say 2 minus 4 is negative 2. But this is really 2 minus negative 4. And then for the y, it is negative 2 minus negative 5. Make sure when you simplify your signs, that really becomes a plus, and that really becomes a plus. So we have 4x to the 6th, y to the 3rd. Be very careful with your signs and trying to do too much in your head. Once you have those two down, go ahead and move on. Here's our final example. This is a problem that kind of ties everything together. We are going to treat this as two separate problems, this one and this one, and when we get done, we will multiply those two answers together. So let's go ahead and look at the first one. I hope you see that there are parentheses with an exponent that needs to be distributed. Be very careful and take your time. This would be 16 to the 2nd power times x to the 10th power. Now, did any of you think to stop and say, wait, you mentioned earlier to simplify what was within the parentheses. Instead of having to do 16 squared, how about we reduce the fraction first? 16 divided by 4 is 4. So we have 4x to the 5th over x squared. That is what's going to be squared. If we do look at our second one right here, before we take this to the 3rd power, let's simplify inside. 8 divided by 4 is 2, and then we have x to the 11th over x to the negative 3rd, and that is all to the 3rd power. So just to recap, what we did was we just simplified the coefficients inside. 16 divided by 4 is 4. Now let's distribute. 4 squared, x to the, do you remember this from the other day? 5 times 2 is 10, over x squared. Now, 4 squared is 16. Now don't forget, here's where we use our division rules. X to the 10th over x to the 2nd. 10 minus 2 is 8. So we have 16x to the 8th times, now let's come over to our blue. We're going to distribute our exponent, so that becomes 8x to the 33rd. Remember, it's 2 to the 3rd power, which is 8. And then we multiply 3 times 11, and we get x to the 33rd. Don't forget to distribute this third exponent to the denominator. That becomes x to the negative 9th. If I were to simplify, that is 8x, and then we've got 33 minus negative 9, which becomes a positive 42. So we have 8x to the 42nd power. Now, we're almost done. I'm just going to move so I have some room to write here. We have 16x to the 8th times 8x to the 42nd. Let's move some of this out of our way. So if we go ahead and multiply, 16 times 8 is 128. X to the, now we're going to add our exponents, 8 plus 42 is 50. All right, that was a pretty complex problem. That's as hard as the exponent unit gets because you had to remember all the rules. So what I'm going to do now is I'm going to walk through the exact same question one more time, and I would like you to watch it and make sure you are good and you have all the work to go with it. You shouldn't have to write anything, you should just be watching. We're going to take our first set of parentheses. We're going to reduce inside. 16 divided by 4 is 4. And then I have x to the 5th over x to the 2nd. Now we could actually simplify the x to the 5th over x to the 2nd because 5 minus 2 is 3. So we simplified. Now that is going to get squared. 4 squared, and then the 3 times 2 is 6. That is 16x to the 6th. Let's take our second set of parentheses right here. Let's reduce. 8 divided by 4 is 2. And let's look at our x's exponents. 11 minus negative 3 becomes a positive 14. We're going to take that all to the 3rd power. So I simplified by reducing coefficients, and then I subtracted my exponents. Now I'm going to distribute my power. 2 to the 3rd power, and then x to the 42nd power. Yep, just double checking my multiplication. There we go. All right, let's go ahead and simplify. 2 to the 3rd is 8. 8x to the 42nd power. If we multiply our two terms now, we're going to do coefficient times coefficient, which is 128, and then we're going to add our x's exponents. 42 plus 6 is 48, which makes me believe that my other exponent of 50 was incorrect the first time. It should be x to the 48th power. So make sure you take a moment, double check your final answer that you have 128 x to the 48th power, please. Once you're good with that, you are done with your notes. Oh, I take that back. You are done as far as me walking you through step by step, but what I would like you to do on this very last example is I'm going to ask you to pause the video and then see if you can do this one on your own, and then check when you're done. So how did you do? Were you able to come up with 2,000? X to the 43rd. If not, take a moment and look. In blue, I simplified. There was nothing to reduce the 5 with, but x to the 3rd over x to the 2nd is x to the 1st. Now I distributed and got 5 to the 3rd times x to the 3rd. 5 to the 3rd is 125, and that leaves us at 125x to the 3rd. Next term right here, 2 to the 4th, when we distribute, but before we distribute, let's simplify. There's nothing to simplify the 2 with, so there's my 2. But for the exponents, we have 7 minus negative 3. Well, 7 minus negative 3 becomes 10, so it's 2x to the 10th. Now we distribute our exponent, 2 to the 4th, x to the 40th. 2 to the 4th is 16, x to the 40th. Now we multiply these two terms together. 125 times 16, coefficient times coefficient is 2,000. And then we add the exponents of our like letters and get 43. Once you are good with that problem, you are officially done and ready to begin your 9.2. So my final question for you before you end the video is, how do you feel? Are you able to use all of the rules? The product, the power, the quotient, today's new ones, the zero and the inverse rules, to simplify exponential expressions. If you feel you are good, you are done with your notes, and you are ready to begin your assignment.